Hi there. So, Servus Berlin, as we say in Austria. Thanks for having us, and we're excited to be here with you. That's us. I'm Thomas, and you can find me on Twitter at THPNK.
And my name is Fabian, and I'm Fabian_Friedl on Twitter. And we both work at a company called Dynatrace. And Dynatrace builds a software intelligence solution. So starting from a user's click in the browser down to the database transaction, we monitor every part of your stack and can give you valuable insights into your application. So we feature nearly every technology. And so if you run your Angular app in a Docker container somewhere in the cloud, we can probably tell you what's happening.
Yeah, as we said, we are from Linz, Austria. You might know Austria for its beautiful mountains, lakes, and cozy villages, for one of the best skiing slopes in the world, and for very chilled wildlife. But most people get confused. We don't actually have kangaroos. That's Australia, if you know. Yeah, and Linz is actually the third largest city in Austria. And if you want to step by, it's right between Munich and Vienna. So here you can find us right at the Danube. So our talk is called It's Just a String, Learnings from Building a Component Library. And to give you a little sneak peek on why we have chosen this title, let me reformat it. And we will continue this topic shortly. So let's start. Let's start with the scope and motivation why we are building a component library at Dynatrace. So there's a big why. The Dynatrace component library is right now used by over 300 developers in multiple teams, building multiple apps around the globe in all our locations. And our goal is to provide high quality and easy to use components that scale.
And to manage all of this, we have our design system called Barista, because we like coffee. And our design system helps us scale, streamline, and automate all of our UX design and UI development processes. And it's also our single source of truth for our components. And it includes getting started sections, accessibility information, UI patterns, and much, much more, like resources, icons, and presentations that you can download. And one of the sections in our design system contains our Angular component library, including documentation and information on how to contribute, our coding standards, and our changelog. And our component pages contain people that can help you out if you're stuck. You have ready-to-copy code snippets and interactive demos that you can try out yourself, API documentation, and usage guidelines on when to use what component. And if you're interested, please check it out yourself. We have a public version of our design system on barista.dynatrace.com, or you can use the QR code. And if you want to hear more about how we scale our component library, please also check out the awesome talk our colleagues Katrin and Stefan gave at this year's NG Vikings. So about API design, there are a couple of things that we learned the hard way when it comes to designing the APIs of our components. So it's not that easy as you might expect at the first try. But there are a couple of rules that we follow, and they helped us out a lot. So let's take this example. Let's consider you want to have a card component and your UX colleague tells you the card will have a title and it's going to be a string. And the first try of an API for you might be something like this. So you would put an input on it, and it takes a string, and you render it somewhere in your template. Looks simple at first. But then some new UX requirements and project management requirements are sprinkled on top. And what previously was just a string now contains HTML markup. So this is problematic. You can, of course, hack together something where you insert it into the DOM or use inner HTML or something, but there are better solutions out there. And we're using content projection for this. So we have a couple of directives and components that are projected into the card component, and we render those out into different sections. So this enables us to fulfill the initial requirements, but also plan ahead and be safe for new requirements coming in from UX or project management without having us break the API.
Yeah, the second rule we try to follow is to stick to what devs already know. Let's look at this native select. And of course, we try to make our API for our select as close as possible to native HTML elements. Because devs already know how a native select works, so they also know how our select works. We also try to look at Angular material for some components that are also in our component library, look at their API, and check if we can make it as similar as possible if it fits our needs. And this gives us the benefit that new developers that are onboarded on our company can have a super fast onboarding and know what they are doing.
Another rule or challenge that we have is we try to keep APIs consistent across components. So at the top, you see a card component rendered in the browser, and at the bottom left, you see the tile component that we have, and besides that, the code for each one of those. And by having consistent APIs, we make sure that the developer is already aware for the second component if you use the first one. So by having consistent APIs, we mean everything starting from tag names to inputs, outputs, and method names. So in the best case scenario, a developer that used one of your components doesn't even have to look at your documentation to figure out the second component that he tries to use.
Another rule we try to follow is that we build for a data structure you cannot control. Since you cannot control what data the user puts into your component or your component has to face, you should never force a consumer into a specific data structure. Our components are data structure independent. The consumer provides us data via, as Fabian said, ng content, data sources, controls, and accessor functions that are passed into the component. For example, let's look at an API for a select, and let's say we have a data structure like this. One way would be to create an input on the data select that takes the data structure as an input, and we internally then render the options so the user can click it. But this is kind of problematic. The downside to this approach is that you force the user into a specific structure. The structure has to be an object that has a value and a label. A much better solution is to create a declarative API, where the user provides the data via an additional option component and loops over it via ng4. He also defines what of the data that is passed in is the value of the option and what is the label of the option. So the user has actually the freedom and can use whatever data structure he wants to use. The next big topic on building a component library is that you have contracts with your users and your consumers in place. That makes it very easy for them to consume your component library and they know exactly what to do and what to don't do. This is important because you want to avoid stuff like this. So the integration of your components library should not feel like this. Also, look at the last one now. I love this. You want to see it again? It's so funny. I can. Yeah, so the first contract we try to rely on is that we prefix everything that goes public. This helps our users to clearly distinguish between symbols that are provided by the library and their own. And it helps with debugging, so you can clearly see, for example, in your DOM, what elements come from the library and what don't. And it gives you another safety layer, for example, for view encapsulations. But be aware, choose your prefix wisely. It will stick with you a long, long time.
In addition to prefixing everything that goes public, we mark internal and private properties and prefix them with an underscore. So what do we mean by internal? By internal, we mean those properties that you have to make public because you're using them in your own templates, but you don't want to expose them as part of your public API of your component. And we prefix all of those properties, including the private ones, with an underscore, and for the internal ones, we add the @internal decorator or JSDoc annotation for the JSDoc comment. So this means that all our users that use our components have the clear contract that they know, so they know that whenever they're using something prefixed with an underscore, they're probably doing something wrong. And those internal and private properties are not part of our semantic versioning.
Yeah, so as Fabian mentioned, we have a strong commitment to semantic versioning. Yeah, but there was a story, kind of, before introducing Semver, we were like, this. And that's kind of how we started, but we quickly noticed that we need a different approach for new versions. And we started introducing semantic versioning to our library. And this helped us a lot because users now know exactly what to expect for new versions and different version bumps. So if we look at a version like this, the user knows exactly when we increase the patch version, this could only contain bug fixes. When we increase the minor version, this can only contain additional features. And if we release a major version, only a major version can have breaking changes.
We also try to work with deprecations for our APIs wherever possible. So sometimes you have to change something in your API, but we try to use deprecations. And we try to keep deprecations for at least one major version after we introduce them, and we mark them in our code with the @deprecated annotation. And we also include the version when they will be removed. So we can generate some stuff out of it, and this helps users know when they can expect the deprecated API to be removed, and they can actually plan ahead to switch over to new APIs that we introduce. Also, if you're building your component library, try to schedule your releases and be predictable, especially when it comes to major versions. So what we are doing, we try to release a new patch and minor version once a week, and we plan major versions quite some time ahead. So we are announcing our upcoming major versions in our Slack channels, and this helps our users plan ahead for potential breaking changes, and it makes it easier for everybody that uses your component library to stay up to date and stay on the latest version of your component library. So we already covered a lot of things, but there are more things that you should be aware of when it comes to building your own component library, and the Angular CDK is one of them. We already heard in the first talk today that the Angular CDK comes with a lot of features, and the Angular material team really provided an awesome toolset for you to build your own component library called the Component Development Kit as part of the Angular Components repository. And we are heavily using it in nearly all of our components. So if you're not already using it, do so. It's really awesome, and it helped us a lot. So we encourage you to check this out as well.
Yeah, this is kind of a story I have to tell. So when you build a component library, prepare for the worst. Or let's say it in other words, prepare for the things you cannot control. What do you mean by that? Let me explain by looking at change detection. As you might know, change detection is one of the core concepts that drives Angular. It tracks down changes of the state of a component and tells the render engine to make those changes visible to the browser. You also might know that the change detection is tree-based. So when we look at a component tree like this, with an app component on the top, an overview and a detail component, and a card and a button component that are the children of a detail component. Let's say we want to click a button. The change detection kicks in. It starts traversing the component tree, starting at the top with the app component, bubbles down to the overview detailing component, goes to the card component, and so on until it reaches a leaf, the button component. So what's happening if we change the change detection strategy of the detail component to onPush? When we now click a button, the change detection kicks in. It starts again at the top with the app component, traverses down to the overview component, reaches the detail component, but now we have a problem there. Because we have set it to onPush, the change detection will only continue to run there if one of the inputs of the detail component has changed. So as we didn't change the input of a detail component when clicking the button, the change detection will never reach the button. And this is the reason why all our components in the library are set to onPush per default. So we don't rely on the change detection to reach our component. This is needed because we don't know where our components that we ship in the library live in the component tree of the apps that uses our library. And this also leads me to a point when building a component library that assume nothing and set everything. As we have seen some of the properties that you set on the metadata object of, of a component, these properties might depend on the parent component. So as a component author, you need to make sure that the components you are building work the same way no matter where the component is placed in the tree. So in our case, every component of the library has change detection set to onPush, has preserved whitespace set, and has view encapsulation set, because we don't know in what part of the component tree we live in with our component and how we are behaving then there.
Another thing that we try to do with the component library is that we try to build it platform independent. So you should, you as a developer of your component library, you don't know where your components might be used. So they are probably going to be rendered in the browser, but they might also be used in a Node.js environment and for universal rendering on the server, or even a worker. So therefore, avoid direct DOM access. You should, of course, let Angular handle DOM manipulations by using the template, but sometimes you have to do more stuff. And if you need to do more, in those cases, make sure to check whether you have a document in place or use the render abstraction layer of Angular to access the DOM. And this makes sure that all your components can be rendered on any platform and not only in the browser.
The next big topic we are handling here is testing. And for us, testing is really an essential part of the development process. And we have extended it quite a lot over the time. Of course, first, when we started the component library, we started with our unit tests, as you might know from the Angular CDK, our end-to-end tests. And yeah, that's how we started. but we quickly noticed we also want to test if our components are actually platform independent, so we added universal testing to the pipeline. This universal testing suite basically just renders every component in a Node.js environment via Angular Universal, and if a component can't be rendered, the pipeline fails. Another thing we added to the pipeline is integration testing. So we run our components against a lot of apps internally at Dynatrace, against some repositories, and check if the tests are failing with the new versions and if maybe the linting is failing and stuff. We also added accessibility testing to our pipeline via X. It's an accessibility testing framework. You should definitely check it out. And we added visual comparisons to our pull requests. So when we look at a pull request like this, our build master adds a comment to the pull request and attaches a visual diff. And when you look at it, it opens up, and you can see exactly what changes visually in your pull request. And this helped us already a lot, because sometimes you do changes in your code base, which you might think do fix only a small bugs, but in reality you introduce a lot of changes to the visual appearance of a component. So long story short, test as much as possible and improve over time.
Another key aspect of building your own component library is actually community management. And for us, this means that we try to be as transparent as possible in all of what we do. So we are having open discussions about API proposals for new components or changing APIs in our Slack channels. And we also try to help new contributors with API proposals they post, and this helps us making sure to have consistent APIs across the entire library, and it makes sure for new developers that they get the support early when they need it. And we also have our dedicated Slack channels that we're using if somebody needs direct feedback or gets stuck because he doesn't find something in the documentation.
In the early days of our library, as you might know, you have always some lengthy discussions, what is the best formatting of your code and how to define your coding guidelines. We got rid of all of those quite early by clearly documenting coding contributions and coding guidelines. And we automated things like formatting by using the prettier and therefore avoided then bike shedding.
And you can also build awesome tooling surrounding your component library that helps you in your daily work or improves developer experience for your users. So what we are doing is we are shipping custom linting rules, and you can write your own custom linting rules quite easily. And we do this because some of our components need to be put together from various parts, and some of them might be required, like the title. Other things like ARIA labels increase how accessible your applications are, and therefore should be linted as well. And because we want to provide feedback as early as possible for the developers, we created those linting rules, so they can already get it during development and not only at build time. And these rules helped us a lot in improving the quality and consistency of our UIs, and they make sure that the components are accessible and used correctly.
As described earlier, where we talked about deprecations, they can get quite complicated to manage over time. With different versions of our component library, more and more apps are using it. It felt quite hard to keep track of deprecations and the usage of our component library, especially the different versions that are out there. So our colleague Tom Heller built an awesome tool. It's amazing. It scans all our repositories at Dynatrace, looks for all the repositories that do depend on our component library, and tracks if they are still using deprecated functions, deprecated components, and if what versions they are using it. So the tool gives us insights into the usage of a single component, and we can track how it changes over time, as well as we also get the big picture of what components different repositories use.
So if you want to build your own component library, keep the following key takeaways of our talk in mind. Try to create good, consistent APIs and provide documentation for everything that you're doing to have an amazing developer experience.
Program defensively. Prepare for the changes and new requirements and for the data structures you cannot control.
And communicate as much as possible. Try to be open, try to be transparent about what you do, and provide a changelog, announce releases, and especially help new people who want to contribute to your component library.
Thank you for having us. That's us. We will tweet out the links to the slides later, and we're looking forward to chat to you in the breaks. Enjoy the conference. Thank you.
Thanks.